7th edition of AgriLevante, but first edition with a new area which is dedicated to digital technology. Alessio Bolognesi is with me as in charge of digital technologies for FederUnacoma. Thank you for having invited me. What can we see here in this area? As you were saying, this is the first time that AgriLevante hosts this area, and that's because digital technologies in agriculture are increasingly important. Different subsidies were allocated also in the past for buying the technology. This is why it is necessary to offer a general overview in order to instill the interest in technology, because technology aids and supports agriculture from several points of view. So, what about the three categories of robots which are visible in this area? Well, there are different robots. There are some live demos, and for those who want to visit this exhibition, there are 3 live sessions, live demo sessions in the morning and the afternoon, where people can really appreciate all these categories. We have flying machines, what we usually call drones, and drones are unmanned aerial vehicles, which can be included into 2 categories. There are also the land-based machines, machines that can make an analysis of the soil with different kinds of sensors or cameras to capture a number of parameters from the vigor of the plant, weeds, infestations, color, number, size of fruits, caliber of fruits. Many other parameters can be appreciated, and analysis can be done at a very high speed, which is not the case for human operators. And these machines can provide a lot of indications to carry out precision agriculture. Precision agriculture is based on data. This is why it is important to gain as many data as possible. And there are the drones, unmanned aerial vehicles for the treatments. The most common ones are for spraying, air spraying, but there are also drones which are able to deliver predators for crop pests in a site-specific manner, for example, for organic agriculture. Well, there are different applications. Then we have the same 2 categories in terms of machines. Machines for sensing, for the analysis of the crop and of the field, machines to make specific treatments, an atomizer for vineyards and for fruit orchards, which is a robot, it's an autonomous, and there are machines for carrying to carry tools. So, for example, there is a machine for vineyards capable of that may be equipped with different kinds of tools for carrying out different types of activities along the row in a vineyard. The fact that live demo sessions are organized is very interesting. Well, these robots are electrical. All the robots which are here are electrically powered. Well, we speak of environmental sustainability in the field of agriculture, and sustainability is very important. These machines are also able to, for example, there are also batteries that can be replaced, and therefore it is possible to work continuously during the day, which is not the case, for example, for big tractors. Whereas for these smaller machines, it is possible to change the battery, and in half an hour, the battery out of power can be recharged. And the sensors on these robots are also able to work in different conditions, in conditions of dust, in the dark, at night. They have no limits or in any case, there are technologies to overcome specific constraints, so they can work round the clock, which is a big advantage at low cost. Another advantage, and speaking of sustainability, these machines are light. They do not have an impact on the soil when they work. So you see a lot of applications and a lot of advantages derived from the fact that they are powered by electricity and they are lighter with respect to a traditional tractor. We see it from these pictures. It seems that the future is now with these new machines in agriculture. Now, agriculture, what about the application of these machines in agriculture in terms of percentage? Are they already used, or are these robots for future applications? We decided to call that area REAL. It's an acronym, but REAL because it's a reality. Because these machines are available on the market, they are already applied practically in the field. They are not for the future. Technology evolves, no doubt about it. We'll have increasingly performing versions, more advanced versions, but these machines already exist. And they also fill gaps in the field of agriculture. The first is the sustainability. I mentioned environmental sustainability, but let me say that a farmer has to combine this aspect also with the economic sustainability of agricultural practices. A farmer has to make an earning. A farmer has to produce in good conditions. A farmer has to produce healthy foods. And the only way to do that is through technology. Traditional agriculture has limits because we need data, we need information. And we also need machines that can be increasingly precise in order to optimize all the aspects of agricultural practices. And only the advanced digital technology can do that. And in the meanwhile, agricultural robots can also satisfy other requirements, for example, labor force, especially the phases of a harvest, especially for fruit and vegetable growing or in the fruit orchards. Well, there is no more labor force available. This is why, in the meanwhile, it is also important to produce fruits and vegetables and to sell fruits and vegetables on the markets. This is why these machines are becoming a very important part of the future of agriculture. So, REAL is the acronym for what? Robotics and electronics in agricultural life. Thank you to Alessio Bolognesi. Thank you.